Go.
All right, I'm going to be doing the solution to number 255. All right, you want to find the number of trials, and you want to be at least 95% confident, so you have 0.95 is equal to the probability of 0.95 mu less than or equal to x bar, and then x bar is less than or equal to 1.05 mu, because you want to have it 5% away from the mean. All right, so then you standardize that and you get 0.95 is equal to probability of 0.95 mu minus mu over sigma over square root of n less than or equal to z, which is less than or equal to 1.05 minus mu over sigma over square root of n. And from the given information, you know that sigma is equal to 1.2 mu. So I'll just go ahead and plug that in and make necessary adjustments. Probability of -0.05 mu over 1.2 mu over square root of n less than or equal to z. So you have 0.05 mu over 1.2 mu over square root of n, and of course you can cancel out the mu's. And so you go in and use a standard normal table, and you get that 0.05 square root of n over 1.2 is equal to 1.96, and then you go ahead and you solve for n, so I'll just do all the manipulations. Go to 1.96 times 1.2 n is equal to 1.96 times 1.2 over 0.05 squared, and you get n is equal to 2,212.76, and so answer choice B. All right, I am going to be doing the solution to the SOA problem 220. First, you must find out the number of simulated claims. And in order to do this, you got to use the probability mass function for a Poisson distribution with mean equal to 4, which is pk is equal to either the negative lambda times lambda to the k over k factorial. You use this to find the individual probabilities, and then you create the cumulative distribution for the, So for P0, you get 0.0183, and over here, I'll have cumulative distribution. You get 0.0183 for x greater than or equal to 0, but less than 1. And then over here you have P1 is equal to 0.0733, and you add that to this and you get 0.0916 for x greater than or equal to 1 less than 2. And now you get P3 is equal to 0.1463, you add that to these, and then you get 0.2379 for x greater than or equal to 2, less than 3. And now you can use the inversion method for u equal to 0.13 to get the simulated number of claims. So 0.13 is in between 0.0916 and 0.2379. And so you say the simulated number of claims is equal to 2. And now you can simulate what the actual losses are for each claim. You simulate 2 of those. Using the inversion method, you get u is equal to 1 minus e to the negative x over 1,000, which is the mean. And you solve this for x, and this is the exponential distribution. So for u equal to 0.05, you get, I'm just going to do all the manipulations. E to the negative x, 1,000, you go to 0.95, 1,000 is equal to ln of 0.95, and you get x equals negative 1,000 times ln 0.95, and you get 51.29 for that loss. And now for u equal to 0.95, you get you get 2,995.73. And now you add up these two for the total losses, and you get 3,047.02, which is the SOA answer choice D. Okay, I'm going to be doing the solution for the SOA problem 237. You're going to have to simulate the claims by using the inversion method, so you get u is equal to this with z equal to ln x minus mu over sigma. All right, for u 0.6217. You're going to have to go to your normal tables and find the z value to give you this probability, and so you get z equal to 0.31. So now you have 0.31 equal to this, ln x minus mu over sigma. So now you solve for x, and I'll just do the manipulations. Ln x minus 131 sigma plus mu equals x, and x equals e to the 0.31 mu plus, or sigma plus mu, and so the values given were mu equal to 5.6 and sigma equal to 0.75, so you get x equals to 341.21, and you apply the deductible and you get a payment of 241.21, and now for u equal to 0.9941, you get a z value of 2.52, and you get x equals to 1,790.05, and you get a payment of 1,690.05, and now for u equal to 0.8686, you get a z value of 1.12, and you get x equal to 626.41, and you get a payment of 526.41. And now for 1.0485. You get a z-value of negative 1.66. And so you get an x equal to 77.87. So your payment's going to be 0 since the deductible is more than it. And now for your average payment per loss, you add these up, divide by 4, and you get 641.42, which is answer choice A.